This is your video for Accentuate the Negative Investigation 2.1, where we are going to move on to addition with rational numbers. But for this video, our learning target is going to be to add using an algorithm. So we're going to start with some new vocab, and then we will take a look at some examples of how we can start to get away from always using the chip model or the number line model and maybe speed up the process of addition. So our first new vocab is algorithm. It's kind of hard to add with an algorithm if we're not even sure what that is. So by definition, an algorithm is a plan or a series of steps in order to do our addition. So it's plan or steps to do the problem. And then one way that we can help make the problem a little bit easier, depending on the numbers that we have, is to use the commutative property. And the commutative property is for addition, and it allows you to move numbers around. So for an example, I might have something like 3 plus -4 plus 3 plus -7. So the commutative property says that you can switch around the location of those numbers, and that can sometimes make it a little bit easier to add. So I could transfer that to be maybe putting the positive numbers together, 3 plus 3, and then putting the negative numbers together. Sometimes it's helpful if we can group numbers that are similar or have the same sign. So with addition, the same thing actually happens with multiplication, that you can rearrange the order that you have those numbers, and sometimes that can make the addition or the multiplication a little bit easier. So let's take a look at a couple groups of numbers. We have group 1 and group 2. And the first thing that I would like you to do is pause the video and one last time represent each one of these addition problems using the chip model. I'm going to use the black and the red again. You may use any color of your choosing. Just make sure you have one for negative and one for positive. And once you hit play, you will see all my chips on the screen. Alright, hopefully you have all your chips on the board. I know there wasn't a lot of space. The first thing I want to do before solving these is to look at some of the observations between group 1 and group 2. So one of the things that I noticed in group 1 is that for each question I either had to use all black or all red. And then what that showed me is that for each one I was either adding 2 positive numbers or 2 negative numbers. So in group 1 I have numbers with the same sign. Oops. And that's going to be an important thing to note. And then in group 2, for each question, there was a combination of black and red chips. So what that showed me is that in group 2, I had numbers with different signs. So now let's go through, and I did not put the answer of each of these with chips since I was running out of space. But 2 plus 8, if I were to count up all my chips, I would end up with 10 black chips, so it would be a positive 10. A negative 2 plus a negative 8, I would end up with 10 chips again, but because they are red, I have a negative 10. Then I have 8 plus 12, all black chips. Oops. And if I were to add those up, I would have 20 chips, and because they are black, it would be positive. And then I have a negative 8 plus a negative 12, which would once again give me 20 chips, but because they are red, oops, it is a negative 20. So let's take a look at group 2. Here I'm adding with different signs. So you may already have done this, but if I have 2 black and 8 red, I know that the 2 black and 2 red, they cancel each other out. That leaves me with this group of red left over, which means I have a negative 6. Then I switched those around, and now I have a negative 2 with a positive 8, but still 2 black and 2 red cancel each other out, leaving me with that boxed group that is left, leaving me with 6 black, or a positive 6. Next I have a positive 8 with a negative 12, and so 8 of my black and my red would cancel each other out. And that leaves me with a group of 4, which is red, so I have a negative 4. Then on my next one, a negative 8 with a positive 12. Again, 8 of them would cancel out. Once again, leaving me with a group of 4, but this time they are black, so I have a positive 4. So what we want to look at is what the examples in each group have in common. Well, we already started a little bit looking at that, where group 1, they all have the same sign. Group 2, they have different signs. And hopefully you've already recognized that now between group 1 and group 2, I'm using the same numbers. I'm using 2 and 8 consistently to hopefully help us see what's happening a little bit easier. And I'm also always using addition. So I'm using addition. I have the same numbers, and then I have groups with the same sign, and then a group with a different sign, which we've already noted. Hopefully, you can see that in group 1, because I end up with the same color chip, I simply add like normal. And if it's all black chips or all positive, my answer is positive. And if it's all red chips, because both of the numbers are negative, then my answer is negative. So I would like you to write 2 new addition problems that would belong in group 1, not using the numbers 8 and 12. I'm going to come up with 2, and I want you to come up with 2. So go ahead, pause the video, quickly write down 2 problems that would look similar or that belong in group 1, and then see if it looks close to what I have. Alright, I wrote down -4 plus -9. That fits with group 1 because they both have the same sign. It just happens to be negative. My second example was 3 plus 6. That fits with group 1 because they both have the same sign, and in that case, they're both positive. So in group 2, we had one number that was positive and one number that was negative. So I would like you to write down 2 examples that belong in group 2, once again not using the numbers 2, 8, and 12. Alright, I wrote down 7 plus -3. One number was positive, one number is negative. And then 9 plus -4. So I changed from group 1, where I just converted the 9 to be positive, so that I would have one number being positive and one number being negative. Alright, so we need to now describe an algorithm for adding integers. What you should be seeing is for group 1, for numbers that have the same sign, you need to add like normal. So go ahead and write that down. Numbers with the same sign, and you go ahead and classify that that is group 1. You're going to add like normal. And you're going to attach the sign of the numbers. So if both numbers are positive, your answer needs to be positive. If both your numbers are negative, then your answer needs to be negative. Alright, but what about group 2? Numbers with different signs. If you have not already seen it, if I just take the first example, 2 plus -8, my answer is a -6. Well, if I think about how do 2, 8, and 6 relate to one another, well, I know that 8 minus 2 gives me a 6. Would that hold true if I were to use the numbers 8 and 12? Well, 12 minus 8 gives me 4, and that was the number that I had to use in my answers. So adding with one positive and one negative, we can treat the problem like a subtraction problem. So let's start by writing that part down. Oops, I'm kind of running out of space. I'm going to go ahead and put it up here. So numbers with different signs do subtraction. Then, in order to determine if your answer is positive or negative, you need to take the sign of the bigger number. So here, 8 would be a bigger number than 2. 8 is negative, so my answer is negative. And the second one, 8's larger and it's positive, so you can see that my answer is positive, or there's no negative sign there. And the third one, the 12 is a bigger number and positive. My answer was positive. And then it switches to the 12 being positive, so my answer is positive, or having the lack of a negative sign in there. So numbers with different signs, you do subtraction and take the sign of the bigger number. That algorithm, along with the previous one, is going to help when we need to add rational numbers together. So let's look at a couple of examples. Here you have to remember your skills for adding with not only fractions, where you need to find a common denominator, but also with decimals, where you need to ensure that those decimal points line up. So in the first one, I noticed that I have one positive number and one negative number. So I'm going to treat this question, following our algorithm, like subtraction. So I'm going to have 8.35, and I'm going to subtract 5. This is where it's key that you line the numbers up. 5 is like 5.00. And even though I'm adding, I'm going to follow my algorithm where I treat it like subtraction. And I start over in the tenths place value. So 5 minus 0 is 5. 3 minus 0 is 3. The decimal point comes straight down. 8 minus 5 is 3. So my answer is 3.35. Now I need to determine, is that a positive or a negative number? Well, my algorithm says that I need to use the sign of the bigger number. My bigger number happens to be 8.35. And since that carries the negative sign, my answer would be negative 0.35. All right, try the next one on your own, and then once you hit play again, you'll see my answer. All right, negative 8.55 plus 5.3, but because those have two different signs, one positive and one negative, I can treat it like subtraction, and I end up with a negative 3.25. All right, the next one, go ahead, try that one on your own as well, and then hit play again and see how you did. All right, another example where you could treat it like subtraction. I came up with negative 3.4, or it would be fine to say negative 3.40. That does not affect your answer. All right, the next one, we have two negatives. So think about having two groups of red chips. Because they would match, we can add like normal. Here I'm going to use the commutative property, and I'm going to put 9.27 on top, and I'm going to put the 5 on the bottom, remembering that it's 5.00. So 7, 2, decimal point comes straight down. 9 plus 5 is 14. Because they both have a negative, my final answer is negative. So negative 14.27. All right, the next one also, they are both negative, so we can add like normal. But in this one, we have fractions. And in order to add fractions, you have to have common denominators. So we need to change these first before we can move on. Since finding common denominators is a review skill, I would like you to try and find your own common denominator, and then once you hit play, you'll see which common denominator that I chose. All right, I chose a common denominator of 15, so 10 and 4/5 went to 10 and 12/15, and 5 and 2/3 went to 5 and 10/15. And again, both those numbers are negative. So I like to, when adding with either decimals or fractions, I like to stack my numbers. Remember, we do not add denominators. So I have 12 plus 10. I'm going to write over here, gives me 22/15, and I'm just adding like normal because both my numbers are negative, and 10 and 5 gives me 15, or a negative 15, and 22/15. We cannot leave our answer like this because of our improper fraction right here. So we do need to convert that. So this portion right here would become 1 because 15 goes into 22 one time. And that leaves me with 7/15 left over. Then this portion has to get added to the -15. So -15 with an extra 1 gives me a -16 and 7/15. So that's the final answer. Those fraction ones can be a little bit more complicated and take a little bit longer. Alright, the last one I really just added to once again show the commutative property where you can add numbers in a different order. And hopefully, if you looked ahead, you can see that I have 2 7s, one positive and one negative. I'm going to put those next to each other and then put the -2 and 7/8 at the end. The reason for that is because these two numbers are opposites of each other. And a -7 and a 7 gives me 0, so really those just, they cancel each other out. That leaves me with just the -2 and 7/8. So it may take a little bit of time to get comfortable with the algorithms, especially when you see addition, but you're going to treat it like subtraction, so we'll continue to work on these skills in class.